All right, let's solve an engineering mystery.
So you install a brand new transformer, but it just keeps tripping. What's going on?
The weird part is, your meters say the load's only at 65%. That's tons of headroom.
And yet you're getting a 100% thermal overload alarm. Yeah, that just doesn't add up. The culprit? It's often hiding in plain sight, your variable frequency drives, or VFDs. See, these VFDs generate what's called dirty power, or more technically, harmonic currents.
And it's not random. A standard VFD actually creates a pretty predictable pattern of these harmonics.
But what's really key here are the 5th and 7th harmonics. They're the biggest troublemakers. We're talking about total harmonic distortion that can hit anywhere from 35 to 80%.
And here's the kicker. All these invisible harmonics create very real extra heat.
A big chunk of that heat comes from something called eddy current losses. And check this out. The higher the harmonic, the worse it gets. The 7th harmonic, 49 times the loss. So your meter says 70%, but the transformer is literally cooking itself from the inside. On top of that, harmonics cause the skin effect. It's kind of like a traffic jam for electricity. And all this extra heat is a disaster. Just a 10 degrees Celsius rise can cut its life in half.
Okay, so how do we fix this?
Well, that brings us to the K-factor rating.
Transformers with a K rating are built differently. They're designed specifically to handle this harmonic heat.
So you've got two choices. Run a standard transformer way below capacity, or just get a K-rated one.
Yeah, the K-rated one costs more upfront, but its total cost of ownership is way, way lower. So what's the right move for your facility? It's actually a pretty simple 3-step process. First up, you gotta know how much harmonic distortion you're actually dealing with in your system. Then, you take that data and figure out the exact K-factor your specific setup needs. And finally, you just match that number to the right transformer. Simple as that. Which really leaves us with one big question. What's the true cost of ignoring this invisible problem?